Hey you guys, I wanted to put together a quick video of the three rules you're going to be learning today about exponents and how they appear in math. So last week we just did a review of what an exponent does in any type of expression or equation and how that works as an operation within math. So these three rules are going to apply to when our bases are the same. So the first rule up top in the left is the product rule. So when you hear the word product, you should kind of think, oh, that means that there's going to be multiplication involved in this problem. When I see the word quotient, it means that you're going to see division somehow expressed in the problem. And when we see the power rule, we already know that a power is another word for an exponent. So this is when we are going to put exponents with exponents, okay? So the first one that we have is the product rule. And in the videos on Khan Academy that I want you to watch, they're going to explain that when we have multiple bases being multiplied by each other, each one of these exponents has a power of 1. So if we were to rewrite this, this would be a to the third power. So the product rule is pretty much saying when you see that a problem has multiplication and it has the same bases, since these were all the letter A, all you do is add the exponents together. So I want you to write this down. Take some notes. You add exponents when the bases are the same and it's a multiplication problem. So this is the product rule. The other thing that I want to keep in mind is sometimes you have coefficients. So let's say I had the problem 3x to the second times 2x to the fifth. You still treat it as multiplication. So 3 times 2, it's still just what you learned in 3rd grade. 3 times 2 is 6. Therefore, we would simplify this to say 6. The bases, which are x, are also the same. So we're allowed to do what we just did in the problem above. This would become x to the 7th power because we said that we have to add exponents when the bases are the same. Now let's jump to the quotient rule. So the quotient rule can be expressed a few different ways. They could use this symbol that I used right here, or they could use it as a fraction. So you're going to see them as fractions today, and we're going to do the same thing. If I say a to the third power over a to the first power, this is technically a division problem. There's a quotient here. And instead of adding the exponents like in the product rule, you're going to subtract the exponents when the bases are the same. And you can only do it when the bases are the same. So write this down. Quotient rule, we subtract exponents. So the way that this would simplify is I'm going to subtract, we get a to the second power. Now the thing that's tricky about this is if I were to rewrite this expression up here and show you how they cancel out, a to the third over here we said was a times a times a. So I'm going to write that out, a times a times a over, on this portion down here, I have 1a. So if I put an a down here, you should know that through canceling, I'm really left with 2 a's. And that's what we said as our answer. We said 3 minus 1 gives us 2. Therefore, our answer is a to the second power. That's why there are 2 a's here. Okay? So now if I rewrite this problem and I say a is on top, or a to the first power, over a to the third, well, we would say 1 minus 3 is a negative 2. So this is how I'm going to teach you this right now. Next week it's going to be a little different. But if I rewrite this out, it would be a over a times a times a. If we did our same canceling technique from above, we're left with nothing on top of the fraction. So technically there's a placeholder of 1. And on the bottom we have 2 a's. All right, so there is a difference in these problems. Look at our final solutions here. When we did this one, when the 3 was on top, it was a to the second. When the a to the third was on the bottom, it was 1 over a to the second because we needed that placeholder. So as you go through today, the way that I like to teach this to students is think of which part of the fraction has more a's on top. So in our original problem, we had more a's on the top here. Okay? So as you start to subtract, ask yourself, where are there more a's? That's where they're going to stay. So let's try another example problem. If I do x to the fifth over x to the seventh, ask yourself, where are there more x's? Technically on the bottom, because there are 7 as opposed to the 5 that are on top. So if I do my subtraction right now, I'm going to get a negative 2. And we know that where there are more x's is where the x's are going to stay when we do this rule. So it's going to become x to the second, and there's nothing left on top, so we have a placeholder. If I switch this around and I gave us the problem of x over x to the 7th over x to the 5th, that's going to come out to just x to the second. And technically it is over 1, but we don't need that over 1. It's not necessary. I'd like to do one more quotient rule with you, keeping in mind what happens if we have coefficients. So let's say you get a fraction and we have 2 on top, x to the third, and 6x to the fifth. Just like in the problem that we did over here with the product rule, you still treat these numbers as you would a regular fraction. So if I just look at this is 2 over 6. Does that simplify? It does. I can simplify 2 over 6 to 1 over 3. And now I can deal with my exponent portion. So I have 3 x's on top, 5 on the bottom. There's obviously more on the bottom. So when I do 3 minus 5, I get a negative 2, or 2 that are left over. They are on the bottom. So just keep in mind, when you have coefficients, you can't disregard them. You don't subtract those. Just like in these product rules, we didn't add them, we still multiplied them because it was always a multiplication problem. Okay, for the last rule, we have the power rule of exponents, and I want you to pay attention because a lot of students get the power rule confused with the product rule, and it's not the same. And I'm going to show you why most people get this confused. This problem is saying that this a to the fifth is going to be multiplied by itself 2 times, meaning we have an a to the fifth times an a to the fifth. So if we just apply this product rule that we looked at, we said if there's a multiplication problem and it has the same base, we add the exponents together. 5 plus 5 is 10. But now, if I just look at this rule for what it is, a to the fifth to the second power, we are pretty much just multiplying 5 times 2, which is still a to the 10th. So the power rule can show us, can be expressed using the product rule, and that's why people get this confused. So if the product rule said to add our exponents when they have the same base, and the quotient rule said to subtract them when they have the same base, when we're putting a power to a power, we are just multiplying the exponents. So I want you to write that part down. So let's look at some examples of this. I could say x to the 7th power, then to the 3rd power, or it would just become x to the 21st power. All you do is you're multiplying these two numbers together. It's almost like you're distributing. So let's see what happens when we have more than one base. So if I say x to the 6th, y, z to the 2nd, all put to the 3rd power, it's almost like distributing, like I just said. Each one of the exponents that are here are going to be multiplied by this 3. Now if there isn't an exponent, we always assume there's 1. So this is going to become x to the 18th, y to the 3rd, z to the 6th. Okay? Same thing if I had put a coefficient in front of this problem. Let's say I put a 2 here. Okay? This technically has an exponent of 1. So if I had given you that as the problem and multiplied it, this would become 2 to the 3rd, x to the 18th, y to the 3rd, z to the 6th. If you really want to, which I'm not going to ask you to do right now, you could simplify this. 2 times 2 times 2 would give us 8. So if you wanted to write this problem out as 8 x to the 18th, y to the 3rd, z to the 6th, you would not be incorrect. Please make sure you have these 3 rules because next week we're going to be doing problems that ask you to take all of these rules that you're learning today and incorporate them all together on top of two more rules that you're going to learn next week, which are the easiest of the bunch. Before I let you go, I want to do at least 2 problems from each section, and these are the problems that look very similar to the 3 practice sheets that I'm leaving you for this week. So let's take a look at this first one right here. These would both be considered the product rule. So I have 2 numbers that have the same bases, And our product rule says if you have the same base and you're multiplying, you're going to add the exponents together. So this is going to become h to the 10th. Let's take a look at the second one. The rule said if the bases are the same, we add them together, but you can't forget about the coefficients. So 6 times 3 is still just plain old 18, but we're going to take the bases and add them together. Let's do two quotient rules together. We have r to the second over r to the fifth, so we subtract wherever there are more of the bases. Since there are more r's on the bottom, that's where the number is going to go. So 5 minus 2 is 3. Since nothing is on top of this fraction, we leave 1 as its placeholder. Number 9, this is one that came directly from your practice worksheet. We have 4 and 8, so we simplify it just as we would any other fraction. 4 over 8 simplifies to 1 over 2. We have a y to the second and y to the fourth. So if we subtract that, there's going to be more y's on the bottom. 4 minus 2 is 2. And then we have an r to the sixth power that's just hanging out by itself. There's no r on top. Therefore, it's just going to stay on the bottom, r to the sixth. Let's take a look at two power rules. So I have x to the second, y, this is technically to the first power, and I'm going to multiply the exponents together. So this is x to the 10th, y to the 5th. Simple as that. Let's try another one. This one I have 3p q to the second, r to the third, all put to the second power. So I like to fill in, if there's nothing there for the exponent, I like to put the ones just so that you can see it and visualize it easier. So we're just going to multiply. So this becomes 3 to the second. This one would become p to the second. This one would become q to the fourth. And this one would become r to the sixth. Like I said above, or earlier in the video, this could simplify to just 9 p to the second, q to the fourth, r to the sixth. It's okay to leave it as 3 to the second, but just know that you know what 3 to the second is, so we could write it as 9. If you guys need any other help, please make sure that you refer to the Khan Academy videos. I think they walk you through everything, but I just wanted to put this video together so that you could make sure that you solidify these 3 rules before we move on next week. Let me know if you have any questions. Feel free to email me whenever you want. I miss you guys, and I hope you're doing well.